This is a presentation on the electrical activity of your brain. So the electrical physiology of the brain. The brain is an electrochemical system. Both electrical and chemical signals facilitate communication. For example, medications act as chemical message, and neurofeedback affects electrical activity. The electroencephalogram, or EEG, is the sum of the electrical activity of the neurons in the brain, which can be measured over time from the scalp. Electrode locations are specified by the International 1020 system for most clinical and research applications, except when higher density arrays are used, meaning more electrodes. But generally in private practice offices, this is the system that will be used. Using the system ensures that the naming of electrodes is consistent across laboratories and offices. In most clinical applications, 19 recording electrodes plus ground and system references are used. A smaller number of electrodes are typically used when recording EEG from neonates. This is what the electroencephalogram looks like in its raw activity. So this is what we would be looking at on the computer screen while we were recording electrical activity from your brain. Each brainwave has a different shape and can be recognized. The delta are the very slow waves from 0.5 to 4 hertz, and so we're able to separate out the activity from each frequency from the overall electroencephalogram that we looked at. So there's a raw wavelength, and then the machines that we use in the computer are able to separate the components. So delta would be 0.5 to 4 hertz, which is 0.5 to 4 cycles per second. It's predominant in certain parts of sleep. It is important for rest and consolidation, so it does serve a good purpose. However, high amplitudes of delta can interfere with emotional or cognitive processing. It should be less dominant while a person is awake. Theta is 4 to 8 hertz, which is 4 to 8 cycles per second. It's important for creativity and memory consolidation, but if there's predominant theta activity, it can look inattentive, distractible, or lack of focus, and a person can be in a trance-like or hypnagogic state with too much theta. Alpha is 8 to 12 hertz, which is 8 to 12 cycles per second. It's usually an aware and relaxed state. It's the neutral or idling rhythm of the brain. It's important for mental flexibility, so it's the state we go through between resource recruitment and allocation from one task to the next. It's increased in meditation, and it ranges from a meditative, more internally focused state to a relaxed, alert, kind of prepared, ready for the next task state. SMR, or sensory motor rhythm, is 12 to 15 hertz. And this frequency is only designated as SMR on the sensory cortex, so it's in a particular part of the brain. If there is sufficient SMR rhythm, it looks like a calm attention to external events. It regulates impulsivity and hyperactivity, promotes body awareness, helps control anxiety and anger, and encourages movement regulation. Beta, so this is kind of the lower end of beta, 15 to 20 hertz or 15 to 20 cycles per second. It is the state that promotes active attention to external events, enhances cognitive processing, may improve concentration and attention. Excess beta activity may be related to anxiety. There's higher beta from 22 to 36 hertz or 22 to 30 hertz depending on which person you talk to, but it's the higher beta. It represents a high state of arousal, can be excited, anxious, or stressed, may be related to obsessive thinking and or hypervigilance and body tension.